Voice is getting differently. Only there. Join. Samita, what's the class is there before? Which class was this, Samita? Class was there, ma'am, before? No one is joined. Samita, are you getting my voice?
Yes, sir. Yes, sir.
How many members were there, ma'am, for the before class?
1 second, sir.
Huh? They are going to be logging or not? Okay, ma'am. Anyway, they're going to be logging or not. So at least we'll start the class. Okay. Hi, Aditi.
Hello, sir.
Okay. Right, ma'am. So you read complete solutions? Yesterday, whatever we discussed, everything you finished or not? Complete. So Sunday, that means tomorrow we have a complete chapter, full solutions chapter is there for the test. So here one more concept it is there. So actually it's not the concept here. So based on this one we already discussed about the Van 't Hoff factor. So what is meant by the Van 't Hoff factor and that all means here? Van 't Hoff factor is nothing but it is the ratio of observed qualitative property by calculative properties. And what is the another definitions we had given? Observed osmotic pressure by calculated osmotic pressure. So that is also it is that. Okay. And here, the number of ions formed after the association or dissociation by the total number of moles of molecules taken in a solution. So all these formulas, based on all these formulas, we are going to calculate the Van 't Hoff factor. Okay. And so based on the Van 't Hoff factor, we are going to calculate the degree of dissociation and degree of association. So what is meant by the degree of dissociation means alpha is equal to I minus 1 by n minus 1. What is the degree of dissociation means here? Degree of dissociation is nothing but alpha is equal to I minus 1 by n minus 1. Okay. In this one, what is meant by the n is nothing but number of ions. N is equal to number of ions. Van 't Hoff factor minus 1 by n minus 1. Okay. And degree of association. Degree of association. So degree of association means what is the formula we are taking? Alpha is equal to 1 minus I by 1 minus 1 by n. Okay, so 1 minus 1 by n. So in this one, let's see here. Based on this one, again we are going to explain the qualitative properties also. Based on Van 't Hoff factor also, we are going to explain the qualitative property. Sir, how we are going to explain the qualitative properties means here? So relative lowering vapor pressure. Relative lowering vapor pressure. So how we are going to represent the relative lowering vapor pressure? What is the formula we are writing for the relative lowering vapor pressure? RLVP is equal to, how we can write the formula? RLVP is equal to P naught minus PS by P naught is equal to I into mole fraction of the solute. Okay, with respect to the Van 't Hoff factor, how we can write the formula for the relative lowering vapor pressure means P naught minus PS by P naught is equal to I into XP. And similarly, elevation of boiling point. Elevation of boiling point temperature. Elevation of boiling point temperature. Elevation of boiling point temperature. So what is the formula we are using for the elevation of the boiling point temperature? Delta TB is equal to KB into M. But with respect to the Van 't Hoff factor, how we can write the molecular power? What is the formula we are writing for the elevation of boiling point temperature means? So delta TB is equal to I into KB. I into K into KB into M is the formula. And depression of freezing point temperature. Depression of freezing point temperature. Depression of freezing point temperature. Freezing point temperature. Depression of freezing point temperature. So how we can write the depression of freezing point temperature formula means here? Depression of freezing point temperature. What is the formula we can write depression of freezing point temperature, Aditi? What is the formula we can write for the depression of freezing point temperature? Samita, what is the formula we can write for the depression of freezing point temperature?
Delta TF is equal to I KF into M.
Delta TF is equal to I into KF into M. Okay. And osmotic pressure? Osmotic pressure. Osmotic pressure. So for osmotic pressure, we can write the formula pi is equal to IC ST. So these are the formulas. So based on this one, we have a sum questions. Okay, so based on this one, we have a sum questions. So I forwarded some questions, whether you practiced or not, I don't know. Anyway, we'll discuss some other questions. Previous year questions only. Now, so based on the Van Top factor, which type of questions they're asking means here. For example, here one question they are given Van Top factor. Based on the Van Top factor, what is the question they asked here? Which of the following salts has the same value of the Van Top factor I? Which of the following salts has same value of Van Top factor I of, write the question. That's one question here. So which of the following salts has the same value of Van Top factor I as that of K3 FeCN taken 6 times. K3 FeCN taken 6 times. So this is the question. Options. First option. So what is the first option means here? Na2SO4. Second option. B option is AlNO3 taken 3 times. AlNO3 taken 3 times. And C. Al2SO4 taken 3 times. Al2SO4 taken 3 times. Option D. NaCl. So what is the answer? How we can identify the answer? Which one? So what is the answer for this one, Aditi? Any one of you? First of all, what I'm telling that Van Top factor. So what is meant by the Van Top factor? Van Top factor is nothing but the number of ions present after the dissociation by total number of molecules we had taken. So according to that one, I is equal to K3FeCN taken 6 times. What is the Van 't Hoff factor of the K3FeCN taken 6 times? We have to calculate. Okay. So what is the Van 't Hoff factor of the K3FeCN taken 6 times means we have to know what are the ions when it undergoes to the ionization. If the K3FeCN taken 6 times it undergoes to the ionization means it forms 3 moles of the K3, 3 moles of the K plus and 1 mole of FeCN taken 6 times to the power of 3 minus. Okay. The total number of 3 plus 1. So complex ions cannot be ionized. Complex compound that does not undergoes to the ionization. Hence the total number of ions is equal to 4. Okay, total number of ions is equal to 4. So I is equal to, we can write as a number of ions after the dissociation. How many ions we got as here? 4. How many molecules we had taken? 1. So 4 by 1 is equal to 4. The Van 't Hoff factor of K3FeCN taken 6 times is equal to 4. Okay. Now, which of the following salts is having the Van 't Hoff factor is 4? That is the question. So already they had given the options also. Which one is the answer, ma? What is the correct answer? What is the answer, ma? What is the answer, ma? No one is answering. Aditi, Samhita. What is the correct answer? What is the correct answer? I didn't get any answer from you. Aditi, are you getting my voice?
Sir, I can hear you now. There was something wrong with my internet.
Okay. Sorry. What is the answer, Aditi?
Sir, can you once explain it?
Ma?
Sir, can you explain it once? I was disconnected for a few minutes.
Okay. So now I'm going to be explain my here. So here, first they had given question. What is the question they had given? Which of the following salts has the same value of Van 't Hoff factor as that of the K3FeCN taken 6 times? Okay. So this is the salt they had given. Okay. So, and they had given some salts also. Which of the following salt is having same Van 't Hoff factor? For that one, first we have to calculate the Van 't Hoff factor of the K3FeCN taken 6 times. So what is the Van 't Hoff factor of the K3FeCN taken 6 times means you're getting as a 4. Sir, how you got as a 4 means here, when the K3FeCN taken 6 times, it undergoes to the ionization. It forms 3K plus and 1 Fe6 taken 3 minus ion. Got it? So total number of ions in a given solution is 4 are there. 3 plus 1, we have a 4. So this one is, it does not undergoes to the ionization. Because of complex compounds which we are writing in a square brackets, that does not undergoes to the dissociation. That is the clear. Okay. So according to the total number of ions present in a solution is equal to 4. How we can write the Van 't Hoff factor? Van 't Hoff factor is equal to number of ions after the dissociation by total number of molecules taken. 4 by 1. 4 by 1 means answer you will get as a 4. So what is the Van 't Hoff factor of the K3 FeCN taken 6 times is equal to 4. Now, so you got as a Van 't Hoff factor of the K3 FeCN taken 6 times. Like this, they had given some salts. Which of the following salts is having similar Van 't Hoff factor? That is the question. Which is having, Aditi? Which has a similar Van 't Hoff factor? Samhita?
Yes, sir.
So which one is having the similar Van 't Hoff factor? Either sodium sulfate, aluminum nitrate, aluminum
Sir, is
sulfate.
it aluminum nitrate?
Correct, Salina. Correct, Samhita. It is aluminum nitrate. Because of, if the aluminum nitrate is, it undergoes to the dissociation means Van 't Hoff factor you will get as a 4. Okay, this one Van 't Hoff factor is equal to 4. Samhita, can you tell me what is the Van 't Hoff factor of the sodium sulfate?
6.
Ma. Sodium sulfate, ma.
Oh, sorry, 3, sir.
3, ma. And aluminum sulfate?
5, sir.
5 is the answer. Sodium chloride?
2.
2. So Aditi, you got the clarity? Still any doubt is there? Aditi,
Yes, sir.
so you got the answer or not?
Yes, sir.
Okay, right. So then we'll go for the next question. So I'll give the another question here. Some previous year questions I'm discussing. Okay. So what is the another question means? Here they had given at 25 degrees centigrade, the highest osmotic pressure is exhibited by, okay, at second question, at 25 degrees centigrade, the highest osmotic pressure, osmotic pressure exhibited by 0.1 molar solution of 0.1 molar solution of highest osmotic pressure. Okay, now let us see. So here option A they had given us a glucose. Option B they had given as a urea. Option C they had given as a calcium chloride, CaCl2, and option D they had given as a KCl. So which of the following solution is having the high osmotic pressure? Which of the following solution is having high osmotic pressure? The glucose, urea, calcium chloride, and KCl. How we can explain this question? How we can explain? So osmotic pressure formula is phi is directly proportional to, okay, Ct. If you take Van 't Hoff factor also means here Pi is directly proportional to IC. That means osmotic pressure is depends upon the Van 't Hoff factor or not, sir? Aditi? Aditi, what is the Van 't Hoff factor? Or what is this? That means here osmotic pressure is depends upon the Van 't Hoff factor or not? Samhita? Okay. In this case, so osmotic pressure is directly proportional to the Van 't Hoff factor. If the Van 't Hoff factor is going to be increases, their osmotic pressure also is going to be increases. They are telling that all solutions, glucose also it is having 0.1 molar, urea also it is having 0.1 molar, calcium chloride also it is having 1 molar, and KCl also it is having 1 molar. Concentration is same for the all different types of the solution, but the answer is depends upon the Van 't Hoff factor. So what is the Van 't Hoff factor for the glucose and
So
urea?
is the option C.
Very good, Aditi. It is the option C only. Because of Van 't Hoff factor is going to be increases, means osmotic pressure also is going to be increases. Okay. So now glucose and urea, they're having the same Van 't Hoff factor. Van 't Hoff factor is 1 for the glucose and urea. And calcium chloride you are getting as a 3 is the Van 't Hoff factor. Potassium chloride Van 't Hoff factor you are getting as a 2. Okay.
Yes, like using ionization. We can find.
Yes. Glucose and urea are both are covalent compound. They does not
So they
undergo
don't go
the
under ionization.
ionization, sir. If they won't undergo the ionization, means their Van 't Hoff factor becomes as a 1 only. Okay. So which one is having highest to Van 't Hoff factor? That it is having
CH2.
highest osmotic pressure. According to that one, what is the answer means? Answer C. Calcium chloride is having highest osmotic pressure. Clear? And one more question. One more question. One more question. So which of the following, which of the following which of the following which of the following 0.10 molar, it's not the molar here, small m, molar molar aqueous solution will have aqueous solution will have aqueous solution will have lowest freezing point, lowest freezing point. Okay, options. First option is Ki. Second option is C12, H22, O11. Option C. So what is the option C means? Al2SO4 taken 3 times. Okay, Al2SO4 taken 3 times. Al2SO4 taken 3 times. Option D, C5H10O5. Option D, C5H10O5. So what is the answer? So which of the following 0.10 molar aqueous solution will have the lowest freezing point? They're asking to find out the lowest freezing point. How we can calculate, ma'am? Which one is the lowest freezing point? Lowest freezing point, and which one is having the highest boiling point temperature? Also, we can explain this ones. What is the correct answer, Aditi? Samhita? What is the correct answer? Samhita? Aditi? Aditi, what's the answer?
There is an option C, Al2SO4 taken thrice.
Right, Aditi, how you're telling that this answer is 3? How you're telling that Al2SO3 taken 4 times?
So because the freezing point, it depends on corrugative property, right? And Al2SO4 taken thrice has 5, while other like Ki has 2 and other 2 have 1.
1 only. Very good, Aditi. Okay, so actually here freezing point temperature also depends upon the Van top factor. Okay, if the Van top factor is going to be increases, freezing point temperature is going to be decreases. Okay, so number of ions are increases mean that freezing point temperature is going to be decreases. Okay, so here, so according to that one, which one is having the lowest freezing point temperature means Al2SO4 taken 3 times. Okay, same question I'm asking in reverse manner. So what is the question I'm asking here? So which of the following aqueous solution will have the highest boiling point temperature? Same question I'm asking oppositely here. Which of the following 0.10 molar aqueous solution will have the highest boiling point temperature? So how we can calculate, ma? So which one is having the highest boiling point temperature? Which one is having the highest boiling point temperature, ma? Aditi, Samgita. Which one is the answer?
I don't know the answer, sir.
You don't know, ma? It is also same only, same concept only. Aditi,
So is it B?
it's C only, ma. Because of what is the formula we wrote here only? Boiling point temperature. So Van top factor here, relation formula what you wrote, delta TB is equal to I into KB into M. This is only the formula we wrote now. In this one,
Yes, sir.
delta TB also it is depend directly proportional to the I. Delta TB also is depends
Freezing
upon
point
the
is
I.
the lowest, then the boiling point also will be the highest.
Highest freezing point it will be lowest, their boiling point temperature it will be highest, because of we have to heat more energy na to convert into the liquid. After that we convert into the solid gases form. Okay, so that's why the boiling point temperature is going to be increases. And which one is having the least boiling point temperature means here we can say sucrose or glucose also. Okay, so here colligative properties are inversely proportional to the molar mass. Also one concept it is there again. The colligative properties are inversely proportional to the molar mass. Smaller the molar mass, greater the colligative property. Okay, so larger the molar mass, lesser the colligative property. That concept also it is, that is also we have to check it out, because of we got as a two options. As per that one, if you check it out means which one is having the least boiling point temperature means we can take as a, so B and C, B and D. So in that B and D also, which one is the correct answer means again we have to check it out the molar mass, because of colligative property is inversely proportional to the molar mass. So my answer is least boiling point temperature means C5H10O5 is having the lowest boiling point temperature. Sir, have you told this one means colligative properties are inversely proportional to the molar mass? According to that one, I told here. Because of both are getting as the same Van 't Hoff factor. When you got as the same Van 't Hoff factor, means that time we have to check towards the molar mass. Got it clarity? And boiling point temperature also, highest boiling point temperature means number of the ions in a solution. Number of ions are increases. That means solute only na. Solute molecules are replaced by the solvent molecules. If the solvent molecules means surface area is going to be decreases. Vapor pressure is going to be decreases. To increase the vapor pressure, we have to heat at high temperature. That means boiling point temperature is going to be increases by increasing of the number of ions. So due to that reason only, boiling point elevation of the boiling point temperature is directly proportional to high. Number of ions are increases. Their boiling point temperature also is going to be increases. Is that clear? Is that clear? Samhita and Aditi?
Yes, sir.
Samhita, you got the clarity? Okay, ma. So first, let's check it out here. And tomorrow we have a test based on the complete solutions chapter. Okay.